In this video, we will discuss about multiplexer and implement them using Verilog HTL. All right. See, there are different types of multiplexer like 2 is to 1, 4 is to 1, 8 is to 1, 16 is to 1, etc. But in this video, we will only discuss about 2 is to 1, 4 is to 1, and 8 is to 1 multiplexers. This is the definition of multiplexer. You can just read it. We will directly jump into the 8 is to 1 multiplexer. This is the representation of a 8 is to 1 multiplexer. These are called as data inputs and these are select lines. See, based on these select lines, data input, one of these data inputs will be directed to the output or connected to the output. All right. Let's take an example. Like let's consider I naught as 1 and all other as 0. How do you give the input? 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1 as the input. That is data input. All right. And if the select line is 0, 0 and 0, then I naught will be connected to the output. All right. Then the output will be equal to 1. That's it. This is the truth table. All right. Let's see the Verilog code for 8 is to 1 mux. See. Before that, how do you know the number of select lines in a multiplexer? See, this is 8, right? This can be represented as 2 power 3. All right. 2 power 3 value is 8. See, so if 2 power n is equal to m, then m is the number of data inputs and n will be the number of select lines. That's it. Nothing else. This is the code. See, in 8 is to 1 bucks, the number of data inputs is 8. So it is declared as 8 bits and number of select line is 3. So it is declared as 3 bits and output is only single bit because this is a multiplexer. In multiplexer, only one output will be there. So it is declared a single bit. This is like a switch case in C or Java. If select line is 0, then the output y will be assigned to d of 0. And if 1, d of 1. That, so on and so forth. All right. Let's see the output. See, here the select line input is 111 and data input is 0, 0, 1, 1, 0, 1, 0, 1, 0. All right. See, 111 means I7. Here in the data input, this is I0, this is I1, this is I2, this is I3, this is I4, I5, I6 and I7. So this will be the value of the output. That's it. So if you see in the code, for this particular output, this case will be true and this case will be true and y will be assigned to 0. All right, that's it. Similarly, it's same for 4 is to 1 and 2 is to 1 multiplexers as well. See, 4 is to 1 means 2 power 2. 2 power 2 is equal to 4. This is the number of select lines and 4 is the number of data line inputs. All right. See, let's again take an example. Like this is 0, this is 1, 0, 1, 0. So let's say if you have given the input as 1, 1, then the output will be m is equal to 0. Why? 1, 1 means I3. All right. That's it. See, this is the Verilog code. Again, here number of select lines is 2, so 2 bits, and number of data inputs is 4, so 4 bit, and output is of course 1 bit. Again, this case is like switch statements. See here the number of select lines. Sorry, the select lines input is 1, 1, which means I3. All right. So here I0, I1, I2, I3. One will be assigned to y. All right. So here also this case will be true. All right. That's it. And now we will see 2 is to 1. 2 power 1 is equal to 2. So 1 is the number of select lines and 2 is the number of data inputs. Here only two cases, 0 and 1. If the select line is 0, this will be connected to the output. If the select line is 1, this will be connected to the output. All right. Let's look at the code. again one bit. So number of select lines is 1, so it's 1 bit, and number of data inputs is 2, so 2 bits, and output is of course 1 bit. Again, only two cases for switch statements. This is called case in very long HTML, right? So let's see the output. See here, the select line is 1, so I0 and I1 will be connected to the output. Again, here this case will be true. All right, that's it. Thank you.